We're going to take a closer look at the body fluid testing kit of a previous tutorial. The operations model has got more detail in it than you've seen so far. We're just going to examine some of this now. Just to remind you, this was the flow sheet for the body fluid test kit. There are actually 4 flows in here. There's pre-treating the raw material, which ends up in a stock. There's making a generic, which ends up in a stock. There's making the main formulation and packing, which ends up in a stock. And then there's the final shipment. The master output sheet for the operations model looks like this, as you remember. Now we'll look in greater depth by looking at cost, inventory, time and capacity elements by activity and work center. Cost first. We can plot the variable cost elements this way in what we call a Manhattan diagram. There are 4 types of cost. We've got volume related labor, which is the blue. There is batch related labor, which is the purple. There is good material, which means the value of the material that ends up in the product that the customer finally gets, which is the yellow. And then there is the wasted material, which is something you've bought but gets wasted somewhere downstream, which is in the green. If we go back to the main output sheet, let's take an example. If you look at the total batch related cost there of $580,000, the sum of all those purple bars adds up to $580,000. So this is a breakdown of the costs that you see summarized on the front page. The particular use for this chart is when you're looking for cost savings. Clearly you need to find the big bars, because reducing a small bar isn't really going to get you very much. There's 2 approaches you can take. One is to find a high bar and work out a way of reducing it, or, as we've seen in quite a few examples, find an approach which tackles more than 1 bar at once. For example, batch size of the main stream here between formulation and packing affects 1, 2, 3, 4, 5 batch related labor costs, 4 of them quite large. So if you were to halve the batch size, well, you would double all of those 4, or double the batch size, you would halve all of those 4. Likewise, if you're looking for inventory savings, you might well look at the inventory Manhattan diagram. In this example, most of the inventory value is tied up in 1 raw material. In fact, in this case, we do have a finished goods stock, which is that green bar at the right, but it isn't very large in value by comparison. Then we can look at capacity utilization. The summary output sheet reports the most used work center, in other words the biggest bar, which we can see as formulations in this case, but there's a few other bars that are close behind. Now some explanation about the colors here. Run, which is the blue, is the time that that work center is doing volume related work. So typically you could imagine, for example, in that filling line, that's the time when you'd see liquid going into bottles. The yellow is changeover time, so this is the time that the line is doing a changeover. So in the case of the filling line there, that yellow bit represents the time spent doing changeovers. Or in the case of something like pre-treatment or a calibration, the whole activity is actually changeover when you consider the definition of that term, which is the time between the last good one out of the previous batch and the first good one out of the next batch, which in the case of a QC approval, for example, the only good one comes out is at the end of the process. Likewise with the truck, the product only gets delivered when the truck actually arrives, which is after a period of time. Then we've got 2 other grey uses of capacity. One is not available, for example, a routine maintenance or some other kind of breakdown. And then we have the light grey there, which is what we call unusable at the end of the shift, where you're trying to do something that has to be finished before you down tools and go home, and that usually means that you have some wasted time at the end of the day because you can't start something because you can't finish it. So there's detail there that may be useful. The 4th chart we have here is the lead time graph. It's the way the lead time builds up. Now we said at the very beginning there are 4 streams that we're talking about here. The first one was simply pre-treating the raw material, which is on the left hand side. The second one was making the generic. The third one was going from formulate reagents through to packing. And the 4th one was shipping. Now you'll notice that those 4 streams all end at the same line. The model's set up so that when a stream is independent of another, it finishes at the time of the longest activity. You can see that where activities are actually linked together, that the time builds up as you go from left to right. So you go from formulate reagent through to fill test tube to test to calibrate to pack. And in there again we have some color coding for the time when you'd see something being processed and the time that is when material is being held for some reason. When you change something, all of these things change. So let's change the batch size, which was a major change in here. Change this to bigger middle-sized packing batches. You could see that cost graph suddenly changed, the capacity graph changes, the inventory graph changes, and the lead time graph changes. So we have automatic updating as you make changes. Let's summarize. The only change that is not a compromise is one where all business measures get better, or at least none get worse. This is almost true in this scenario, though not completely true because inventory actually gets slightly worse. Eliminating one product variant, as in one of the previous scenarios, saves money, time and capacity, but the inventory picture again was less clear. Nonetheless, we have here a very quick and easy way of making those assessments. But it has many applications outside of simple manufacturing improvement. The discussion in this tutorial is Chapter 8 of our book, Bridge of Faith for Operations.